Now, this example introduces testing or experimentation outcomes and how they can be inconsistent sometimes. It would be great if any type of test that was done on something was infallible, but we certainly know that that's not the case. Tests can be wrong. So this example shows an EPT test. An EPT test is an early pregnancy test. You could purchase one of these tests at your local pharmacy or any local pharmacy. And it says, in many medical diagnostic tests, the accuracy of the test can be described in terms of the percentages of false positives and false negatives. A false positive means the test shows that a condition exists when in fact one does not exist. A false negative means the test shows that a condition does not exist when in fact one does exist. Pregnancy tests look for the presence of human chorionic gonadotropin, which is HCG, in the urine or blood, as this hormone is present only when a woman is pregnant. Suppose that 96% of women who use an EPT kit are actually pregnant, and they're confirmed through their doctor. A woman who suspects she is pregnant purchases an EPT kit that shows a false negative 2.2% of the time and a false positive 1.7% of the time. So certainly the first thing we're going to do is we're going to go ahead and represent this circumstance as a tree diagram. And what we have here is a woman suspects she is pregnant, so she's going to go out and buy this EPT kit. So I'm just going to put down W here for woman. And there's two possible outcomes. Either she's actually pregnant. I'll just label that with a P. And of course, that occurs 96% of the time. So we'll go ahead and label this as 0.96. And the only other outcome is that she's not pregnant. And I'm going to label that as P complement. And that's got to be 4% of the time. Now, to branch out from here, what I like to do is, since we're talking about false negatives and false positives, we want to determine what is an incorrect outcome. So I'm going to branch out, and what would be incorrect? Well, if she's pregnant, then incorrect would mean a false negative. If she's not pregnant, what would be an incorrect outcome? That would be a false positive. Now, some people like to mark it as incorrect, correct, yes, no. I like to keep it in terms of false negative and false positive because as we move on, some of these examples can get a little more sophisticated and it's easy to get lost. So I like to mark it this way. The only other outcome for a false negative is if it's not a false negative. So I just mark it as its complement. And the only other outcome for a false positive is if it's not a false positive. And again, I just mark it as its complement. For a false negative, right here it says 2.2%. Therefore, for that not to occur, so doing it this way, it's easy to see an outcome and then its complement, an outcome and then its complement. For the false positive, 1.7% of the time. And then its complement. So now we created the tree diagram that represents this circumstance. Then all I like to do is up here, 0.96 times 0.022. That's 0.02112. For here, 0.96 times 0.978. That's 0.93888. For here, we're going to take the 0.04 times the 0.017. 0.00068. And then last for down here, 0.04 times the 0.983. 0.03932. So now we have all the probabilities listed. So then the questions are, so we have these 5 questions here, A through E. For the first letter here, A, it says, if the EPT test shows negative, in other words, it determines that the woman is not pregnant, what is the probability that the woman is pregnant? So up here, it shows that the woman is not pregnant. She actually is pregnant, but the test is saying that she's not. That's a false negative. So that's 0.02112. And it's also showing that she's not pregnant down here. She's not pregnant, and the test goes ahead and confirms it. So then we add that to the 0.03932. So if the test shows negative, it shows it here, and it shows it here. What is the probability that the woman is pregnant? Well, she's pregnant here. That's this group right here. .02112. That's 0.02112. 0.06044. So this comes out to be approximately 34.94%. For letter B, it says if the EPT test shows positive, in other words, it determines that the woman is pregnant, what is the probability that the woman is not pregnant? So here she is pregnant, and this is not a false negative. In other words, the test confirms it. So that's 0.93888. And here she's not pregnant, but it's showing that she is pregnant. 0.00068. So then what is the probability that the woman is not pregnant? So this is what we want. We want this group right here. .00068. That's over 0.93956. So this is approximately 0.07%, so very small. So we continue. Letter C. If the EPT test shows negative, what is the probability that the woman is not pregnant? Again, it shows negative here. In other words, she's pregnant, but it's saying that she's not. And it shows negative down here. The woman is not pregnant, and it confirms it. So again, we have 0.02112. We'll add that to the 0.3932. So then what is the probability that the woman is not pregnant? Here it is right here. 0.03932. This is 0.03932 over 0.06044. So for C, this comes out to be approximately 65.06%. Similarly for D, we'll continue to D. If the EPT test shows positive, what is the probability that the woman is pregnant? It's positive here. She's pregnant. The test confirms it. She's not pregnant, but the test says she is. So we have 0.93888 add that to the 0.00068. So what is the probability that the woman is pregnant? Well, here she is right here. 0.93888. So this is 0.93888. Over 0.93956. So then this comes out to be approximately 99.93%. So what is the sum of these probabilities? So if I was to add this probability and add this probability, add this probability and add this probability, it'll total to 200%, not 100%. And the reason it's going to total to 200% because there's two different outcomes. One is the false negative and the other one is the false positive. If a woman is pregnant, then the test is going to be correct 99.93% of the time. That's reflected here in letter D. If a woman is not pregnant, then the test is going to be correct 65.06% of the time. So the test is much more accurate if the woman is actually pregnant than if she's not pregnant. And there we go.